right, so now we're going to do the same thing, but we're going to use a different reference angle. We're going to use a reference angle of 60 degrees, and we're going to take a look at the 4 bow tie angles, the 4 related angles on the unit circle that have that reference angle of 60. So take a look at my diagram. What I've done is I've drawn an angle in quadrant 1, 2, 3, and 4. They all have a reference angle of 60. Think about where that reference angle is located. The reference angle is located between the x-axis and the terminal side of the angle, all right? In addition, where have I drawn my altitude? From the point where the terminal side hits the circle down to the x-axis, okay? It's all about the x-axis here. So I've got my 4 angles. I've got 4 right triangles that have appeared because I've drawn in 4 altitudes. Let's talk about how big those 4 angles are. In quadrant 1, initial side to terminal side, that's just 60 degrees. In quadrant 2, initial side rotating to terminal side, that's essentially half of the circle, 180 minus 60. 180 minus 60 means this angle is 120 degrees. Let's go into quadrant 3. Initial side rotates around to here, right? That's essentially a semicircle plus 60. 180 plus 60 is 240. That's the angle in quadrant 3. And quadrant 4, starting initial side, rotate around here to the terminal side. That's going to be a 300 degree angle. It's a full circle minus 60 degrees. All right, so we've got 4 related angles, 4 bow tie angles: 60, 120, 240, 300. All right, let's talk about how we can come up with all of these coordinates for the points where the terminal side hits the circle. Again, it all comes down to what you know about special rights, what we know about 30, 60, 90 triangles. So what I've done is I've taken just this 30, 60, 90 in quadrant 1 and I've pulled it off here. There's a 60 degree angle in the bottom left. There's a 90 degree angle bottom right. That means your 30 degree angle is up top. I just haven't written it in here. We know the relationships of the sides. We know that if side W is across from 30 degrees, then the hypotenuse across from 90 is 2W, and therefore the side across from 60 degrees is W root 3. This is the unit circle. The radius of the unit circle is always 1. That implies then that we know the hypotenuse of this triangle is 1 unit because that radius is 1 unit. Therefore, W must equal 1/2. Therefore, W root 3 is 1/2 times root 3, which I'm going to write as root 3 over 2. Okay, so I now have my distances. I actually know the lengths of all the sides in this triangle. Therefore, I know the lengths of all the sides in this triangle. This bottom piece here is 1/2. This piece here that goes vertical, root 3 over 2. Superimpose that in your brain over to this triangle. To get from the origin to that point, I have to go over 1/2 up root 3 over 2. Both are positive. I'm moving in a positive direction. Well, what about this triangle? Again, it's a 30, 60, 90, but now I'm in quadrant 2. I have to go backwards on the x-axis, negative 1/2, and up root 3 over 2. Same values, I just have to make the x value negative. Move into quadrant 3, that 240 degree angle now. Here's your 30, 60, 90. The lengths are the same, but I'm going back 1/2 and down root 3 over 2. X and y are both negative. And finally, in quadrant 3, I'm going over 1/2 down root 3 over 2. So just the y coordinate's negative. So let's pull all that together. Use what we know about sine, cosine, and tangent and how the radius and the x and y coordinates can create your exact trig values. So the sine of 60 degrees, y coordinate over radius of 1. That means the sine of 60 degrees is root 3 over 2 divided by 1. Just root 3 over 2. The cosine of 60 degrees is the x coordinate divided by radius of 1, 1/2. And finally, the tangent of 60 is going to be the y coordinate, root 3 over 2, divided by the x coordinate, 1/2. If you want to see the math for that, that's down here. Root 3 over 2 divided by 1/2. Remember, keep, change, flip. If you are dividing by a fraction, turn it into multiplying by a reciprocal. And what happens is these 2's cross cancel, and therefore, root 3 over 2 divided by 1/2 is just root 3. That's the tangent of 60 degrees. Moving into quadrant 2, 120 degrees. I'm going to see the exact same values repeat. I just have to figure out which ones become negative. So the sine of 120, y coordinate divided by radius, root 3 over 2. The sine stays positive. Cosine of 120, x coordinate divided by radius, negative 1/2. Okay, so cosine became negative. Tangent of 120, y over x, a positive divided by a negative, that's going to be negative root 3. Let's keep the pattern going. Move into quadrant 3. Sine of 240, y coordinate over radius. Sine is negative. Negative root 3 over 2. Cosine of 240. Here's your x coordinate divided by radius. Cosine is negative. Tangent of 240, y coordinate divided by x, negative divided by negative is a positive. It's going to be positive root 3 when I do all that math. And finally, moving into quadrant 4. Quadrant 4, y coordinate divided by radius for sine is negative root 3 over 2. So sine is negative. Cosine x coordinate divided by radius. Cosine is going to be positive 1/2. And finally, tangent y divided by x, a negative divided by a positive, that's going to be negative root 3. So those are your exact trig values for the 4 related angles that have a reference angle of 60 degrees.